Assalamualaikum student. This is a demo video for exercise 1, production of benzene. So if you look at this problem, you have three equipments. You have a heat exchanger, flash 1 and also flash 2. Okay, so first step, you need to choose the appropriate equipment and place it inside your main flow sheet. So main flow sheet is here. So if you click on simulation, so this is your main flow sheet. And at the bottom you have your model palette. And if you scroll down a bit, so you can choose whatever equipment that is suitable depending on your case study. So first, now we put the heat exchanger for cooler. Okay, and next we have flash. So here there are two options for flash 2 and flash 3. So you can refer back to my notes. Okay, what are the to see what are the difference between flash 2 and flash 3. So here it says that flash 2 it has 2 outlet flash. Okay, while flash 3 you have 3 outlet flash. So in our case, okay, the case study for exercise 1, both of these flash 1 and flash 2 is 2 outlet. Okay, it has 2 outlet, one vapor and one liquid stream. Okay, one vapor and one vapor. For flash 2 it has vapor 2 and liquid 2. So both of these flash are flash type 2. Okay, so use this one, click here and just place it on your main flow sheet and put another one. Okay, next you need to put the material stream. Okay, so for the feed, so make sure until that box pop up, feed required, then click one time. Okay, on the output here it say product, so click on the product and click until it touch the feed. Okay, the inlet of your flash 1. Okay, then on top of flash 1 you have a vapor stream. Okay, just bring it up. Okay, and at the bottom here, so don't worry about the label, we can rename the stream label and also the block later on. Okay, so you can move your cursor. Okay, alright. Okay, so settle. Okay, then to change it, if you want to rename it, you need to double click on this. First, press escape. Okay, you can type feed here, and then this stream is cool, and you have vapor 1. Oops. Okay, vapor 2, liquid 1, and also last stream is liquid 2. Oops, sorry. Okay, then you can also rename the equipment, the block. So here it's cool. Okay, it say ID name already exists in stream. So okay, you cannot repeat two name twice. So you need to change to another name. So just put here exchanger. Normally we can just put it as HX. Okay, 01. Okay, and you can drag it, place it here. Okay, next we have flash 1, FL1. Okay, put it here, and you also have FL2. Okay, another thing, to make this more nice. Okay, you can align, click here, align blocks, so you can have a streamline. Okay, here you can align block. Okay, so it's nicer. Okay. Okay, next step is to define the components, methods, and also the process condition. So let's look back at our case study here. So you have hydrogen, methane, benzene, and toluene. So go to properties. Okay. Okay, here they will put component specification. So click find. And normally I'll put equals lah, because if for equals it will be the most accurate one. So as you have hydrogen, and click find now. Okay, double add selected compound. Okay, next you have methane. Okay, just change this to methane and click find now. Okay, add selected component, add benzene, and last one is toluene. Okay, fine. Okay, click and add. So you have all these 4 component. Okay, this is optional. You can also change the component ID. So let's say you can write the full name, hydrogen. Okay, it's up to you, or you can just rename. Okay, so it's up to you. It's optional. You can change the component ID as you wish. Alright, so next, okay, you can click on method here. Okay, and in the question is in your lab also we will specify what property method that you should use. So here it already said you should use Pang-Robinson property method. Okay, go to method, and here and under method name find Pang-Robinson. So this is Pang-Robinson equation of state. So this is actually related with the thermodynamic properties of the species that involved in the case lah. So we will specify it for you. If the question did not specify it for you, you can actually choose method assistant here. This is extra. You can click on method assistant, and you need to answer. Let me see. Okay, start by selecting one of the component. Okay, you can either specify the component or specify the process type. So C component, you need to know whether it's just a chemical system or hydrocarbon system. Hydrocarbon is more to like petrochemicals, special, water only, amines, or refrigerant. So you continue answer the whatever that the system prompt you to, and finally it will suggest the suitable method for you to use. Okay, we will only use this if the method is not specified for you. Okay, so now we already have the methods. Here you see it already still dash red. Okay, so means not ready. You can click on parameter here. Just click on binary interaction. Just double click, and we all write blue tick. Then it's fine. So now you can go back to your simulation. Okay, this is your main flow sheet. So you can define your feed stream. Okay. So look back at the questions. At your feed stream, you have what's the temperature? 1000 Fahrenheit. Pressure is 550 psi. Okay, and here is the component. So you need to define the component first. And look here is in kmol, so you need to change it to lb mole per hour. lb mole per hour. So if the question give you lb mole per hour, then you need to change to lb mole per hour. You can also change it to mass flow rate if you want to. Okay, even mass fraction, mole fraction, concentration, standard volume fraction. So depends on the input that the question give you. So the questions in our exercise give you the molar flow rate. So for hydrogen, it is 405. Methane is 95 pound mole per hour. And benzene also 95. Toluene is 5. Alright. Okay, then you can close this. Next is your heat exchanger. In the question, it says temperature is 200 Fahrenheit and pressure drop is 0. Temperature is 200 Fahrenheit. Okay, make sure need to be careful. Your units must match with the case study, okay? With your problem. Then it says pressure drop. So it's not pressure, so you need to change this to pressure drop. Okay, click. Sorry, it's a bit lagging here. Pressure drop and just put 0 because it's 0 pressure drop. Okay, next we move on to our flash. Temperature is 100 Fahrenheit. Okay, and the pressure is 500 psi. Okay, last one is your flash 2, the process condition for your flash 2. Temperature, okay, they give us pressure and duty. Duty is Q. So for pressure, it is 1 atm. Duty is 0. Okay. So that's all. We have input all the information given. Okay. Components, condition of your feed stream, heat exchanger, cooler here, flash 1 and also flash 2, and we have specified the property method as Penrose-Robinson. Now you can run your simulation. Okay, scroll up. Okay, you can click this. Okay, run. Okay, wait for a while. The simulation is calculating it for you. Okay, is it done? Okay, so once it's done, okay, here at the result summary, this calculation were completed normally, and the status, okay, nothing prompt out here. Alright, so we are done. So you can look at the stream summary. Okay, so this is your cool stream, feed stream, liquid 1, liquid 2, vapor 1 and vapor 2. And you can check what is the molar vapor fraction, So here you have all the details of your stream. Okay. If you scroll down, let's say you want to find the mole flow. Okay, this is the mole flow of each component, and here the unit is in kmol per hour. You can change this to lb mole per hour if you want to. Okay, lb mole per hour or lb mole per minute. So you can choose whatever unit that you are interested in. So this is the input that the value that we input it just now. So feed, only temperature change after it go through the head cooler. So flow rate is still and the molar flow rate is still the same. And then you can look at the value lah. So if the summary here, it won't tell you what is, let's say we calculating for percentage recovery. So you need to know where is the value, and you need to still perform the manual calculation. Let's say you want to calculate the percentage recovery of, what is this, benzene at liquid for flash 1. So 91 divided by 95 divided by 21 minus 91 divided by the original value. Okay, so the idea is basically like that lah. Alright, so if you want to check what's the temperature, okay, here temperature, so it's in degrees Celsius. So your feed stream is let's say 537.78. Then it passed through your cooler, and after that you have a cold stream. So that stream is 93.33 degrees Celsius. So this summary, it tells you all the result, but you need to understand what value you are looking for. Okay, this is for material balance. You can click on heat. Okay, heat. Let me see. Okay, heat. Let's say is more or less you need to look at the value of molar enthalpy or mass enthalpy. So we will look at the details later in chapter 4 and 5. Okay, but right now just focus on the mole flow rate or mass flow rate, mass fraction, and mole fraction. Okay, so that's all for exercise 1. And in case for your labs, I'll probably ask for report. So you need to click on here. So go to home, summary, and report. Just put all, click OK, and copy this. Okay, this is the report. And from here, there's a time where you generate the simulation. Okay, so from here it tells you everything, and you will need to submit this report in your lab when you want to submit your lab later on. Okay, so that's all. Thank you.